In this video, I'm going to teach you something very important. I wouldn't exactly say we are converting from SOP to POS or POS to SOP. It's not exactly that. Okay. So if you have an expression in sum of products form, okay, and you need it in the POS form, okay, and you need it in the POS form, what you can do is actually that's what I'm going to teach you. Okay. So in the future, we will be learning how we can draw logical circuits by only using NAND gates, okay, or how we can only draw using NOR gates, okay. That's what we are going to study in the next step, okay. So during that, you will need an essential skill to convert from these two forms, okay, to convert from and play with these forms. So that's what I'm trying to teach you today, okay. So let's say we have a function z, and that is given as a b bar c plus a b c bar plus a bar b bar c. Okay. Now this is in SOP form, the sum of products form. Okay. But if it is in this format, the problem here is you can't actually use this to, you can't actually use NAND gates or NOR gates to come up with the diagram of this one. Okay. So what we are going to do is we are going to do some arrangements. We are going to do some arrangements, and that's what I'm going to teach you now. What are we going to do is we are going to use double bar on Z. Okay. Why? We know Z double bar is equals to Z according to the double complementary law. Okay. So Z double bar will be equals to A B bar C plus A B C bar plus A bar B bar C whole thing double bar. Okay. Now I can say this is equals to Z, but instead of removing all the two negations or bars, what I'm going to do is I'm going to break the bar inside this bar. This is a bar, this is a bar. I'm going to break this bar by using De Morgan's law. So if I do that, okay, I will get A B bar C. Okay, if I break that, I will get A B bar C. Okay, dot. Okay, whole thing bar dot A B C bar whole thing bar dot A bar B bar C whole thing bar, and this will be covered in another whole thing bar. That's it. Okay, so you can clearly see where I'm going with this. Okay, so what I have done is, if you consider this, okay, if you consider this, we had everything in sum of products form. This is in products, this is in products, this is in products, and it is connected using two OR gates. Now what I have done is, there is a whole thing, but obviously there is an irregularity, okay, but here we have the products. Here we have the products. Now I'm going to break this further down. Okay, if I break this further down, what I will get is, of course, the whole thing bar is going to stay there, but here we will have A bar plus B double bar plus C bar into A bar plus B bar plus C double bar into A double bar plus B double bar plus C bar. Okay, now we have everything that we want. Okay, we have everything that we want. Why? Z is equals to, here you can see this is in sum expression. Okay, it's in the sum format, and we are connecting by using AND gates. So this is actually in product of sum. Okay, it's actually in product of sum. Okay, but only irregularity is this guy. The only irregularity is this guy. Okay, but we'll talk about that. Okay, we'll talk about that. So now we have A bar plus B double bar. So let's simplify everything, because we know B double bar is equals to B. So let's remove everything like that. So we'll have A bar plus B plus C bar into A bar plus B bar plus C into A plus B plus C bar. And this is covered using whole thing bar. So this is what we have. Okay, so this is what we have. Now, if you compare this expression and the expression that we have come up with, this had fundamentally some issues. Okay, this is actually in the sum of products form, and let's say we wanted it in POS form, well, then we can't actually use this. But if you see here, we actually have the POS form, but there is only one single bar. What I can do is, after using this to come up with the circuits in the POS form, I can pass it through a NOT gate and find the answer. I can pass it through a NOT gate and find the answer. So this is why this technique is very important. Okay, using the double bar to convert the structure of the expression. I know this is not exactly what we needed. Okay, we are not converting exactly from POS to SOP or SOP to POS. We are just making some changes so that the structure of the expression changes. Okay, just few arrangements and the structure of the expression has changed. Okay, so this is very important when you're drawing by using only single type of gates like NAND gates or NOR gates. I will be teaching about that in the future lessons. Okay, especially in the next video, I will be speaking about how NAND gates work as universal gates. So this is why I wanted to talk here. Okay, this is what I want to talk here. So I said there is also a shortcut. Okay, there is also a shortcut. Okay, that's what I'm going to teach you now. Okay, that's what I'm going to teach you now. So let's remove all these things. We don't need these things. Okay, we don't need these things. So what we are going to do is, here we have z is equals to a b bar c plus a b c bar plus a bar b c. Yeah. So what you have to do is, you just have to write the opposite of the signals. Here we have A, so you'll write down A bar. Here we have B bar, you'll write down B. Here we have C, so you'll write down C bar. Here actually we have dots, right? The dots are invisible, but that's what happening here. So instead of dots, we will have pluses. And then you will close it. Instead of OR gate, you will have AND gate, and you'll do the same here. So A here, so A bar, plus here we have B, so we have to go with B bar. Here we have C bar, so we have to go with C. Similarly, here we have A plus B plus C bar. Okay, and then just cover it with an entire bar. See, the answers are same. Okay, so just keep this in mind. Okay, just keep this in mind. This is very, very important. Okay, this will be useful when you are doing questions like that. Okay, so it's the same for when we are converting from POS to SOP also. When you're converting from POS to SOP, it's the same idea. You just have to interchange the things. So let's say we have something like P is equals to ABC plus A bar, B bar, C bar plus A bar, B, C. Okay, so let's say this is what we have. Okay, well, this is not in POS, so let's write down in SPOS. So A plus B plus C into A bar plus B bar plus C bar into A plus B bar plus C bar. Okay, so now what I can do is, I can actually change the structure directly. We have A here, so it will be A bar. Here we have B here, so I will have B bar. And here we have C here, so it will be C bar. Instead of plus symbols, I have used the AND gates, okay, or the dots. Then here we have dots, so it will be plus. Here we have A bar, so it will be A. Here we have B bar, so it will be B. And here we have C bar, so it will be C. Plus, here we have A, so it will be A bar, B bar and C bar, so it will be B and C. Now you just have to cover it with a NOT gate. Okay, so if you remove this NOT, if you get to remove this NOT, you will have the SOP form. Okay, so this is what I wanted to bring you today. Okay, this is very important. Why? See here, this whole thing bar and this OR gates clearly show us that they use a NAND gate. I mean, an OR gate. Okay, that's what I wanted to show you here. Okay, so that's the very important thing that I wanted to show you here. So I hope you practice this. Okay, just practice this with random POS and SOP expressions so that it will make sense to you. And it's not exactly important. It's not for beginners, obviously. But if you're trying for advanced level understandings on this stuff, try this. Okay, definitely try this. I'll see you in another video. So stay tuned. Thanks for watching the 20th video in our Logic Gate series. If you found this guide to converting SOP to POS and POS to SOP for universal gate design helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic Gates and follow us on Instagram. I will see you in the next video. Until then, keep learning, stay curious. Bye bye.